In this lesson, we'll clear and finish a part. After completing this lesson, you'll be able to analyze differences between 2D and 3D adaptive clearing, create roughing and finishing toolpaths, and use Simulate to validate multiple setups. Let's carry on with the file from our previous example, and let's start creating toolpaths to cut our soft jaw setup too. Remember that the outside shape and the top face of our part has already been taken care of and is the exact size. So we simply need to clear out this open area here, making sure that we have a nice fit against these edges, and then we need to take care of our G54 probe location pocket. In order to do this, I'm going to get started by going to 2D and selecting 2D pocket. For the tool, I'm going to start with my 1/2 inch flat end mill. This is a 2-flute tool that's good for roughing, so this will be great to get rid of most of the material. For my selection, I'll simply grab this face and note that it automatically shows a blue highlight at the face or the base of our part, so it knows exactly where it needs to cut and what's open. We're not worried about rest machining in this case. We haven't done any machining from this side, but we do want to make sure that the height is based on the selection and that our passes are set correctly. For stock to leave, we have a radial and an axial amount. The radial amount is going to be what's left on the wall of this section, and the axial amount is going to be what's left on the floor of the part, normal to the Z direction. We're not going to worry about finishing passes or anything just yet. We want to take a look at this with a single depth cut with stock to leave set at this amount. So if we select OK, we can see exactly what the toolpath looks like. Now, while this toolpath is great for us to go back and actually finish off some geometry, it's not going to be the best at removing it quickly. So before this operation, I'm going to go back into 3D and select 3D adaptive clearing, using that 1/2 inch flat end mill, selecting the same area, turning off rest machining. Notice that it automatically has stock contours based on the shape of our stock. In the height section, we're going to change the bottom height to be a selection and use this face. And then in the passes section, we're going to leave axial and radial stock of 0.02. Note that there's a machine cavities, there's machine shallow areas, there's flat area detection, which we can turn on. Then it will change the amount of step down that happens in those areas. Then we can also change whether it's ordered by depth or area. We're going to say OK and allow this adaptive toolpath to come in and clear material. One thing you'll notice with the adaptive toolpath is the fact that it's using a lot of jumps to go over that section. So if we go back into our adaptive, go back into our passes, we can say order by area, and we can also take a look at some of the other options that we have in here. For example, we have an optimum load that's based on our tool. We have a minimum cutter radius, again, that's based on that. Well, we can turn on both ways, which will allow the tool to go back and forth without having to make so many jumps. So you'll notice there still are some rapid movements that happen. And if we take a look at our 2D pocket operation, we do have a few rapids, but the adaptive is going to be a better suited toolpath for removing the material while optimizing the load on the tool. So I'm going to drag my adaptive up before my 2D pocket. And note again that we've also explored our 2D adaptive clearing toolpath. So the 2D adaptive clearing is something that could also work in this case as well. So let's take a quick look at 2D adaptive, again using our 1/2 inch flat and again using the same selection. The heights are based off of our contour. We're leaving our radial and axial stock, and we're leaving all the information as it is by default and saying OK. So as we're looking at these toolpaths, we have a 2D adaptive, which I'll drag to the top, and then we have a 3D adaptive. You'll notice that they're very similar, but the 3D adaptive actually has a lot more rapid movements and a lot more movements in general. So I'm going to delete my 3D adaptive toolpath, and I'm going to stick with my 2D adaptive toolpath for roughing out this section. Then I need to decide how I want to finish it. Because we're leaving stock on the bottom and the sides, I'm going to come back and select a different tool. My 3/8 flat end mill is going to be a better suited tool to finish this part. So we're going to change to that tool. The geometry will still be the same. However, the passes, we're no longer leaving any stock, and we want to make sure that we turn on finishing passes. We can turn leads on all finishes, we can change the feed rate, and we can also repeat our finished passes if needed. Because there's material left on the bottom, the finishing pass will cut the entire part on the bottom as well as this face. This prevents us from having to go back and create a contour operation, because you can see there's a final finish step that happens as it goes around the part. Let's go ahead and select this entire setup and we'll simulate it real quick. I'm going to speed this up and watch through the adaptive clearing toolpath. Then we're going to come back and finish it off with the pocket and cut the entire thing. Depending on the type of tolerances that you need to hold, you might want to come back in manually with a contour toolpath, using the pocket to just finish the bottom face, then come back and use something like a 2D contour to have better control over the interaction with the radial stock. The next thing that we need to take care of is this G54 pocket. For this, I'm simply going to come in and do a 2D contour. I'm going to select the bottom edge. I'm going to go into my passes section and make sure that I'm not leaving any stock. Then we're going to say OK. Notice that this fails. If we go to inspect and we take a look at the diameter of the hole, you can see that it's a 1/2 inch. So we're going to come in and we're going to use a smaller tool. So we're going to select our tool number 10, the 1/4 inch flat end mill that we used on the other side. We'll select OK and allow it to generate. Now we'll select the entire setup once more. I'm going to jump past my adaptive clearing. I'm going to jump past my pocketing operation, and then I'm going to play through this to ensure that it clears it out. Again, based on tolerances, you might want to add in additional finishing passes or spring passes based on your geometry. For our purposes, this gives us all the information we need. And if we select both Setup 1 and Setup 2 and simulate, we'll see the material removal from all sides. So this allows us to speed through the process of cutting the slots, drilling and tapping the holes on the bottom, and then seeing the operations on the top. In order to do this, we need to make sure that all the operations are selected, and if we select all the setups, it will also include our multi-axis part. So we want to make sure that we're focusing our attention on just these two before we simulate. So jumping all the way to the end, simulating both of those, you can see that we have a drill and tap operation. We've cut the slots on the bottom. We've cut all the geometry on the top as well as our G54 pocket. So this soft jaw is ready to be cut. And remember, we have two soft jaws that are identical with the exception of that last toolpath. So if we want to make two that are unique, what we can do is we can post the code for just two operations for one of the jaws, and then we can post code for all three of those for the second jaw. The bottoms will be exactly the same, so that program can be run twice. For right now, let's go ahead and make sure that we save our file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.